Hello, welcome to Revelator John. Why does temperature change with a gain in altitude? Well, there are various reasons for this happening. So first of all, if we consider just terrestrial radiation. So initially the Earth receives the sun energy, the sun's rays, which heat up the Earth. Then as heat is received, the Earth also releases heat and loses heat, and this is what is referred to as terrestrial radiation, the radiating heat from the Earth. So it's going to be it's most intense at the Earth's surface, and then as we gain altitude further and further away, we'll start to lose its intensity, and we will start to lose heat. So the further higher we climb, the colder it will become. Also, there is the elements to do with the gas laws. So watch the other videos for the gas laws. But essentially, we have a reducing volume of air as we gain altitude, and as we reduce the volume of air, we also reduce pressure. Once we reduce pressure, then the individual molecules, you might say, are less energized, they're less closer to each other, there are less collisions between the molecules as well, so there is less heat associated with that molecular composition of the air at that altitude, and that gets less and less and less as we gain altitude. One of the reasons that we don't also have a temperature rise as we gain altitude, because the energy derived from the sun only very slightly heats up the atmosphere as the energy passes through the atmosphere towards the Earth itself. So there's little or no heating of the atmosphere. The atmosphere is only heated right at the very top of the troposphere, at the tropopause, where we may see some heating at that level as it breaks through, as the energy breaks through that first tropopause boundary layer. But the troposphere itself, where we have most of our weather, where most of the weather is contained, will not have any heating of the atmosphere. So the other reason why temperature can change with altitude is to do with the moisture content within that atmosphere. So you may have seen the other videos where I've referred to adiabatic lapse rates within the atmosphere, and that is basically air rising lapse rates, and that is to do with whether the air is a moist atmosphere or whether it's a relatively dry atmosphere. So a warm atmosphere has a potential to contain more moisture. So a dry atmosphere has less potential to contain more moisture. So with a dry atmosphere, as we're gaining altitude, there is less condensation. So there's less condensation. When we have condensation, that means that heat is being released by the latent heat exchange process. So therefore, there is no ambient warming of the atmosphere, so it gets colder and colder and colder. There's nothing to heat it up. So we're looking in the region of about 3.5 degrees for every 1,000 feet. For every 1,000 feet gain in altitude. With a moist atmosphere, for a moist adiabatic lapse rate or wet adiabatic lapse rate, there is more condensation as we gain altitude. Therefore is less release of heat to the atmosphere, which slows down, which heats up the ambient atmosphere. So there's slowing down of this cooling, if you like. So for a moist adiabatic lapse rate, we're talking in the region of 0.5 to 1.2, 1.3 degrees reduction in temperature for every 1,000 feet. So an average, you might say, is anywhere between 0.5 and 3. Let's say 2 degrees for every 1,000 feet gain in altitude, 2 degrees loss in temperature for every That's the gain in altitude. But as I said before, that is the reason why temperature decreases with altitude. It's to do with the distance, the physical distance from the Earth itself. It is to do with the pressure, volume of air, and as the reducing pressure and volume as we gain altitude, and it's also to do with the level of moisture within the air and how that affects the dry or moist adiabatic lapse rate. Thank you.